Welcome to More Geometry Glee. Of course we have more geometry glee awaiting you. Tonight we're going to discuss the family tree of quadrilaterals. So we're going to look specifically at several different types of quadrilaterals. Parent of all of these different shapes is just Joe Quadrilateral, and he has no other distinguishing features other than the fact that he has four sides. If we move down the left of our family tree, we can talk about the trapezoids. Trapezoids are unique in that they have at least one pair of parallel sides. At least one pair. Then we move to the child of the trapezoid, which is the isosceles trapezoid. We've talked about isosceles in terms of triangles, but we also have isosceles trapezoids. So the isosceles trapezoid is a trapezoid that also has a pair of congruent sides, those being the non-parallel sides, and base angles that are congruent, and diagonals that are congruent. Now, base angles, keep in mind, could be these two angles are bases because this is one base, and I also have another base up top. There are two bases in an isosceles trapezoid. So these angles would also be congruent. These are base angles. So those are my trapezoids. Now I'm going to move over to the right hand side of the family. And the right hand side of the family, the first figure is the parallelogram. The parallelogram has two sets of parallel sides, two sets of congruent sides, opposite angles that are congruent, and consecutive angles that are supplementary. Because remember, if it has sets of parallel sides, for instance, this side and this side are parallel, then these are parallel lines cut by a transversal, and that follows our rule that these two angles would have a sum of 180. Okay? Now also that means if angle 1 and angle 2 have a sum of 180, well, this line is parallel to this line, so angle 2 and angle 3 have a sum of 180. Well, that means angle 3 has to equal angle 1. So that's our general parallelogram. Now, if you think about the definition of a trapezoid says it has at least one pair of parallel sides. So a trapezoid could, in fact, be a parallelogram if it had more than one pair of parallel sides. Okay, moving down in our family tree. Types of parallelograms. The first one is a rectangle. A rectangle has all the properties of the parallelogram, the parent above it, plus it has four right angles and its diagonals are congruent. The sister of the rectangle is the rhombus. The rhombus has all the properties of the parallelogram, plus four congruent sides, diagonals bisect the angles, and the diagonals are perpendicular. So that's going to mean if I had a rhombus and I show the diagonals here, this diagonal bisects this set of angles, and the second diagonal also bisects the other angles, the consecutive angles next to them, and those diagonals are perpendicular. That means they form right angles. So the diagonals are kind of important in a rhombus. The last parallelogram that we talk about is our friend the square, who says, hey, look at me. I have all of the properties of the parallelogram and the rectangle and the rhombus. I have it all. So a square is always a rhombus. A rhombus may or may not be a square. A square is always a rectangle. A rectangle may or may not be a square. The last thing I want to talk about on our family tree is the sum of the angles in a quadrilateral. Now some of you may know this, but it actually is quite intuitive. If I take any random quadrilateral, so let's take parent Joe Quadrilateral up there, which looks kind of like that, and if I draw my diagonal in here, I create two triangles. And we've already talked about the sum of the measures of a triangle. All of the angles in a triangle add up to 180. Well, all the angles of this triangle add up to 180. So together, the angles of that quadrilateral are 360 degrees, always. Now let's look at some problem solving. I'd like to take a look at our isosceles trapezoids. So these tell us exactly which sides are congruent. They are marked. Those are the legs of the trapezoid. This is a leg. Just like a triangle has legs, so does this. But again, we have two bases in a trapezoid. Now, if I look at that angle, 75 degrees, I can now label every other angle in that figure. And I do so by looking at my relationships. Because I have those two congruent sides, the base angles are also congruent. So that's obviously going to be 75 degrees. Now, when I want to find the measure of this angle, I'm going to consider the relationship established by the parent of this isosceles trapezoid, who is just Josephine trapezoid. Okay? And that says at least one pair of parallel sides. Well, if these are parallel sides, then the missing angle has to be supplementary because these are same side interior angles formed by parallel lines. So this would have to be 105 degrees. And because these are also base angles of the upper base, this one has to be 105 degrees. So why don't you pause here and find the angles in the next trapezoid? Alrighty, so we would obviously have to have 100 degrees here, and because they're supplementary, this has to be 80, and this has to be 80. We're going to continue on with our problem solving for a little bit. You'll need some scrap paper for this. It's not in your notes, but I think you can work on these relatively quickly with just a piece of scrap paper. I think I'm going to let you just pause here and tell me what the missing angles are. Okay, so if you're back with me, I have them all marked in there. The first one, it was just an example of the similar problem we just did. The parallelogram, I know that opposite angles in a parallelogram are congruent, and I also know that consecutive angles, one after the other, are supplementary. In the last figure, I had to have 3 out of the 4 because this is Joe quadrilateral and has no specific features other than the fact that the sum of the angles of a quadrilateral is 360. So great job on these, and we will take a closer look at more quadrilateral problems tomorrow. Have a great night, everybody.